Well, here's a great practical application question. And if you read the question, it says, engineers use vertical curves to improve the comfort and safety of roadways. Vertical curves are parabolic in shape and are used for transitions from one straight grade to another straight grade. Okay, the grade lines are modeled by these three equations. Okay, so you've got a linear one here because that's x to the 1. You've got another linear one here that's x to 1, and there's that parabolic thing that it said in this first statement. Now, what are we talking about here? I don't understand. Well, what's really interesting is that you ask a little kid to draw a bridge over, let's say, an overpass. They're going to draw it something like this. Well, think about how silly that is if you're a car. I mean, as you're traveling to this, you're going to end up crashing into this section right here. So how do we do this? What you do is you make it a very simple grade going upwards. But again, you can't make an overpass looking like this, because again, if you're up here and you're trying to drive over this, this is more of a woohoo and land down here and then drive away. Well, that's ridiculously dangerous. You can't do this. So what happens, in order to get rid of this peak portion here, that's where you introduce a parabola. So what happens here is as you're driving up this road here, you transition from the red straight line to the green line, go over this way and then back, because what happens after that point, this line becomes too steep and it's like you're going to be falling off the side of a building. I don't think you want to definitely do that when you're driving. So you transition back onto the road line, the red line, and away you go. See how this works? So I kind of drawn the scenario out here for you. Again, here, there's your straight line going upwards. Well, I got a question for you. Out of these three graphs over here, which one would be the straight line going up? Well, it would be this one. How do you know? It's got a positive slope. That slope is going up. Then, at this point of intersection, right here, this is where you're going to transfer to this nice parabola. And if you think about this, the parabola is extremely wide, making this transition very, very gradual. And you're just going to go over it. It sure beats going, whee! I'm sure that'd be fun, and I'm sure you've seen that in movies 1,000 times. But in reality, that doesn't happen. And then, when you get to this point right here, you would transition back onto the straight line portion of the road. So these intersection points become extremely, extremely, extremely important. Now, putting this into your calculator, look at the degree of accuracy of this. That's crazy. That's absolutely crazy. Could you imagine doing this in terms of completing the square? I couldn't. How about if we, I got an idea, let's do algebra. No, that's crazy too. So what we want to do here is use technology to solve our problem. So I'm going to take these things, I'm going to put them into my calculator exactly like they are. All right, so I've got my calculator ready to go. I want to make sure that I don't mess up by not seeing these equations right. So I'm going to erase that, bring my calculator back up, and I'm just going to put them in. Here's my y1, 0.08x plus 6.2. Put the next one in exactly the same way. And I'm going to pause the podcast right here. I'm going to put these equations in, and I'll be back in a half a second. Okay, I've got my equations in there, and I'm just going to bring this back over and going to fill up the entire screen again so that we can see it. Now, watch what happens when I hit graph. Remember, this is on Zoom Standard. Oh, watch this. Look at this. What? What? I don't understand a single thing. Well, remember that this particular graph is set up as 10 here, 10 here. So you only got a distance of about 20, in this case, it would be about 20 meters. You don't really see the entire graph, and you don't see exactly what this is doing. So my suggestion is, let's boot this out to about minus 50 and bring this out to about 50 over in this direction. Why would I do such a thing? Because your average bridge over roadway is not going to be 20 meters. It's going to be about 100 meters. By going minus 50 in one direction and 50 in the other, holy smokes, we're going to get about 100 meters, which is about the size of a bridge, proper size of a bridge. So I'm going to go over to this. I'm going to make this about minus 50. I'm going to bring this down. I'm going to make this exactly 50. And let's see what happens. Let's see what this graph looks like now. Well, there's the one line. There's the parabola. There's the other line. Oh, that makes so much more sense. Wow. There's the transition point that I'm looking for here. There's the transition point I'm looking for here. All I have to do now, simple. Second calc, find my intersect. Let's go. Bring it down to this guy. Let's find this intersect right here. There's my Y1. Remember, I'm on the blue line, and this right here on my calculator tells me which line I'm on. I'm on the blue line, Y1. Okay, enter. Look what happens. It goes now to my red line, right? My red line, it even shows me here, there's the squared, tells me I'm on the parabola. Okay, that's great. I want to find the intersection between that blue line and that red line. I'd hit enter, and of course it asks you to guess, giving you an answer here of minus 19.999999. So minus 20 is good enough, and a height of looks like about 4.6 meters high. Okay, there we go. That's our first transition point. Now, let's find the other transition point. Well, same thing. Second calc. Okay, find the intersect 5. Let's move this thing all the way over to the other side onto the black line. Uh-oh, I'm running into problems. I'm still on the blue line. I don't want to be on the blue line anymore. I want to be on the black line. So how do I get to there? Well, simple. You would use this area right here. Let me do this in a different color so you can actually see it. You would use this area right here. There we go. That's what you would use. Notice, to move along the line, we use either left or right to move along the line. I don't want to go left or right. I want to go to the next equation. If you use this button either down or up, it actually takes you, let me get rid of this so it doesn't interfere with what we're doing. Down or up, it actually takes you to the equation. It cycles. Watch this section right here. Watch this section. Just as I hit that red button, it cycles through all the equations that you have. Look, there's equation 1 in blue. There's equation 2, which is the parabola. There's equation 3, which is the black line. If you use that up, down, you can even use it up. Look at this. You can do the exact same thing. It cycles through all of the equations that you have. So I'm going to go onto the black line first. I'm going to hit enter. Okay. Now I want to find the intersection between the black line and the red parabola. Well, I'm on the blue line now. I don't want to be on the blue line. I want to be on the red line. So again, cycle it through. No. Ah, there I am. And just keep hitting the buttons until you find the right answer. Hit enter, guess, and look at that. It's going to give us a really pretty number of 18.75, which is here. 18.75, okay, decimal 75, at a height of looks like 4.70. Perfect. There's our two solutions. There's our two transition points where the car will transition off of this blue line onto the red parabola, off the red parabola and onto the black line and end up going over its bridge. A really cool question and a heck of a lot of practical application. And not only that, some pretty cool calculator techniques as well.